Okay, now let's take up question number 7 from exercise 8.1. Question says ABCD is a rhombus and we are asked to prove diagonal AC. Look at this figure. ABCD is a rhombus. We know rhombus is a figure in which all sides are equal. We are asked to prove that AC diagonal bisects angle A and angle C. This diagonal AC has divided this angle into two equal parts. This needs to be proved, and same thing applies to angle C. And then for the next subpart, we need to prove that BD also bisects angle B and angle D. So let's begin by taking triangle ABC and triangle ADC. It's a clear question because we know if suppose I cut this triangle ABC and paste it on ADC, they would completely cover each other. A would remain as such, C would remain as such, D will be covered by B. Alright, because we know AB is equal to AD. From the other end, BC is equal to DC and AC common. The rule would be triple S rule. SSS would prove this result, and hence by CPCT we can say that these angles are equally divided. Let's quickly write it down. We have triangle ABC. We are taking triangle ABC, and then we are taking triangle ADC. First of all, its AB is equal to AD. Why are they equal? We know they are sides of a rhombus. Next we have BC is equal to DC. Same reason, so I'm just writing do here. Same reason would be written. And then comes common side. Its AC is equal to AC. That's a common side. AC and AC are equal. This is a common side. Therefore, triangle ABC is congruent to triangle ADC by triple S rule. And if triangles are congruent, definitely these angles must be equal. Let us mark these as angle 1 and angle 2. Angle 1 and angle 2 are equal by CPCT. Same way, angles over here, they must be equal. 3 and 4 are equal by CPCT. So this proves our result that AC has bisected angle A and angle C. Similarly, we can prove for BD. By joining BD and applying the same conditions, we can say BD bisects angle B and angle D. Let us now discuss question number 9, another important question. It says ABCD is a parallelogram. Now, when you look at this figure, everything is clearly visible here. Parallelogram ABCD is given, and then there's a diagonal BD. On that diagonal, P and Q are 2 points given in such a way that DP and BQ are equal. We are asked to prove many parts. First one is APD. This is a triangle because when P and Q are points taken on diagonal, then AP is connected, CP, CQ and AQ. All these are connected, and inside also there is one quadrilateral obtained. APCQ is another quadrilateral. So let us see what all needs to be proved. For the first one, they say prove that APD and CQB are congruent. First of all, we need minimum 3 matching parts. First one is clearly visible. Let me write it simultaneously. We would be writing for triangle APD and triangle CQD. Look at the matching parts. First one is AD is equal to गलत लिखता triangle CQB. First is AD is equal to CB. They are opposite sides of a parallelogram. Second matching part is pair of angles which I have already marked. In ADP or APD there is angle 1, because we know when two parallels are intersected by a transversal, alternate interior angles are equal. So AD is parallel to BC and this DB diagonal is serving as a transversal. Angle 1 and angle 2, they are alternate interior angles. Further, we have third matching part which is given in the question itself, which says DP is equal to BQ. DP and BQ are equal. This information is given. Which rule is it? This is, we took side, then there was an angle, another side. So by SAS congruence rule, triangle APD is congruent to triangle CQB. So your first part is done. For the second part, second is straight away, because we know AP is a side of triangle APD and CQ is side of triangle CQB. So if these two triangles are congruent, the remaining corresponding parts must be equal. So AP is equal to CQ. This is by CPCT. For third and fourth part, if I say third and fourth part are completely related to first and second. In first we took triangle APD and CQB. Now for third part we would be dealing with triangle AQB and CPD. Let me quickly tell you how to do this. Three matching parts for third part. First one would be AB is equal to CD. These two are opposite sides of parallelogram. Second one, BQ and DP. This information is given. Third would be a pair of alternate interior angles again. Look at this. AB and CD these two are parallels and this is a transversal. So angle over here, let this be angle 3, and angle at this point, which is angle 4, 3 and 4 are equal. The rule would be side, angle, side again. So once you do for third part, by CPCT you would be able to say that AQ is equal to CP. That's by CPCT. Now finally, when we talk about fifth part, which demands that this figure APCQ is a parallelogram. Look at these two. In first case, if we say AP is equal to CQ, and in the second case we say that AQ is equal to CP, and we know a theorem which says any quadrilateral with opposite pair, with both the pairs of opposite sides equal, is a parallelogram. So from there, from second and fourth, we can conclude that APCQ is a parallelogram. APCQ would be a parallelogram. I'm sure this must be clear, and if there is a doubt, please let me know. Question number 12 from same exercise. It is ABCD is a trapezium. As you can see, there is a trapezium given in which AD, non-parallel sides AD and BC are equal. You know, such trapeziums have got special name. We call them Isosceles Trapezium, in which figures with trapeziums with non-parallel sides equal are called Isosceles Trapezium. So, we are asked to prove. There are 4 parts. First, demands that we should be proving angle A and angle B are equal. Second one is prove that angle C and D are equal. And third is ABC. So we would be connecting diagonal AC and diagonal BD. That we require for third part. And fourth, last one is prove that AC and BD, the diagonals, are also of equal length. So here a small construction is required. The construction is already done. It's done in your textbook even. So I would just tell you what the construction over here is. This is through C, draw a line parallel to AD. Okay, through C we have drawn a line parallel to AD, which meets, where would it meet? Which meets AB at E, such that, now look at this, such that ADCE is a parallelogram. How can we say that this becomes a parallelogram? Observe the figure now. We already know that AB is parallel to CD. Okay, AB is produced, that means AE would also be parallel to CD. DA and CE are parallel by construction. So this figure ADCE becomes a parallelogram. And if it is a parallelogram, what can you say about the sides? As ADCE is a parallelogram, we can say that AD must be equal to EC. But what do we know? We know AD is equal to AD and BC are equal. Equation 1, equation 2 gives us a clear idea. If AD is equal to CE, this is by construction, AD is equal to BC, this is given. So from 1 and 2, we conclude 1 and 2 gives us the idea that BC and EC are equal. BC and CE, they are equal. And if these sides are equal, these angles opposite to them must be equal. Very important. That implies angle 1, angle 2 are equal. Property of isosceles triangle, which we have done in chapter 7. There was a complete theorem on this. So I'm sure you must be knowing that why is it true. Alright, so if 1 and 2 are equal, now what's next? How can this 1 and 2 help us to prove that A and B are equal? As 1 and 2 are already equal, it's proved above. Now let's see, since this ADCE is a parallelogram, can we say angle A and angle 2 would be adding up to 180? They are actually co-interior. Either you write co-interior angles or you say adjacent angles of a parallelogram. In fact, adjacent angles for parallelogram would be better one, because we already know that this ADCE is a parallelogram. Adjacent angles of a parallelogram are, what are they? Are supplementary. Okay, so these angles are supplementary. Now observe this. I would just mark this as 3. At point B, there are two angles formed, angle 1 and angle 3. They are also adding up to 180. This is a linear pair. In chapter 6 we have done this concept of linear pair of angles. So linear pair, on straight line if ray stands, the sum of angles, suppose this is A, this is B, then A plus B would be 180 degrees. Same is the case here. Now, how would these two equations help us? Can I say if A plus 2 is 180, 1 plus 3 is 180, can I straight away equate them? That implies if their RHS is equal, LHS has to be equal. LHS is A plus 2 must be equal to 1 plus 3. 1 and 2 are equal, that is proved earlier. Okay, from there we can cancel these two equals, subtracted from equals, remainders are equal. We have done this. So what is left with us? A is equal to angle 3. What is 3? 3 is actually angle B. So hence your first part is proved, which demanded A and B to be equal. Similarly, we would do for C and D. For second part, observe this. As AB is parallel to CD and angle A and angle D, okay, these two, A and D must be adding up to 180. Which angles? They are co-interior angles. Co-interior angles are supplementary. Same way, angle 3 and angle C. C and 3 would also add up to 180. Same reason, co-interior angles. Their RHS is equal, LHS would also be equal. So I am just writing their left hand side. What can be cancelled? A and 3 or A and B are already proved in part 1. So from here we get a result that D and C are equal. So this proves your second part. Second done, first is also done. For third case, we need to draw diagonals. Diagonal AC and BD. Diagonal AC and BD is drawn. Now let's take these triangles. In triangle ABC and triangle BAD, minimum 3 matching parts are required to prove any set of triangles congruent. First one is clearly seen here, AD and BC. Where is AD? AD is contained in BAD and BC is in triangle ABC. So first of all we would write BC, because when you write it in order, if ABC is written first, so side BC would come first. BC is equal to AD. This information is given to us, and then we have already proved these angles A and B. Triangle ABC has got angle B. Let this be completely written rather than just writing angle B. You know why do I say that it should be complete ABC? Because B is divided into many parts over here. ABD, DBC, then CBE. So let's write ABC is equal to BAD. This is proved above. And one thing more, this is a common side. AB is equal to BA because it would flip itself. AB is equal to BA. This is common. Rule is side, angle, side. Triangle ABC is congruent to triangle BAD by side angle side rule. And if these triangles are congruent, our third part is done. What is left? ABC has got side AC. So AC and BAD has got side BD. So AC and BD are equal by CPCT. So third and fourth are also proved. And remember kids, this is one of the most important questions, so make sure you revise it properly.